Today's talk and presentation plus demo. First, I will talk about the sea level rise feature incorporate into CMS. And in the past, when we project future sea level rise, and CMS, we can set up a constant value, like we doing a storm affected study, and we project in 100 years the sea level in this location will rise by 1 meter. So the CMS can handle a constant increase. You can offset the water level by 1 meter and then make your simulation. And what I'm going to talk about today is right now we incorporate the sea level rise curve into CMS simulation. Like you see in this cover page, there's a sea level rise projection at 0.5 meter to 2 meter, and then based on the sea level rise equation at the top, and then we can have a rising curve, and then we can read this curve now and read into CMS and then make you a long-term simulation. And also after this short presentation, I pick a case and then show how to set up a sea level rise and read the sea level rise curve into CMS and then make a short simulation. The example is only for demo. It's not real. And again, the outline of my presentation, first some background information, and then sea level change in CMS-Flow. And after that, I will show how you can get your sea level rise curve, and how to set up this sea level rise change in CMS, and then after that work with SMS to specify sea level change at model boundary, and then save the file and make your simulation. And those information you probably already know, and so the sea level rise increased sea level rise is due to global warming and rising in ocean temperature, of course. And so for navigation purpose, sea level rise can change channel depths, navigation channel depths, and may introduce more sediment into channel, and we call channel infilling through shoreline erosion, because you have sea level rise, so the more water will go onshore and then make more maybe shoreline erosion, and that result sediment movement. And coast model simulation need to incorporate the sea level rise to assess the future risk and vulnerability of navigation project, and support O&M practice. In CMS and sea level rise, we have a lateral open boundary, right? So this is a boundary have a water exchange with a specification of water level variation. So we need to specify the water level at open boundary. And so the water level we can obtain one from a coastal tidal gauge. So there's a lot of NOAA gauge along shoreline, along coast. So we can get the information, so real measurement from those gauges. And if in some location, if we far away from tidal measurement, so we can compose our water level from tidal constitute. So that's another way to specify water level at the open boundary. So when you run the model, the tidal constituent will make a water elevation boundary for your model. So general formula for boundary condition is look like this. So eta b plus eta 0, eta e, and delta eta over bar. Eta b is the boundary, the boundary water surface elevation. And eta 0 is the initial boundary water surface elevation. Usually this value is, so we set up a start with 0, right? Eta e is specified external boundary condition. That's the boundary condition we get from NOAA gauge, or we get from a tidal constitute. So delta 8 is a water surface elevation offset. That's the value we get from sea level rise information. So as I said earlier, so this value can either be constant and can be varying, and is a sea level rise curve. And so it's specified as delta 8 here. How to obtain a sea level rise curve? And we have a U.S. Army Corps website, and so there's a link here. So if you click this link, you will go to this site, and it gives you sea level rise projection at various locations. So, and this is zoom in. So this is a zoom in of that website. And here there's a parameter you need to pick. Like the example I'm going to show you is in Massachusetts. It's a Merrimack Inlet. So the closest the measurement is at Boston Harbor. And so we pick Boston Harbor here, Boston here. And then the gauge and the scenario source is Army USACE 2013. And then you need to specify some other parameter here, and then output datum and the unit, and also the sea level change rate from NOAA or from USACE. They have different formula, so you can pick. And also you can pick the time period you're going to show this curve. And in the under sea level rise curve, sea level rise folder, we put it there. On the sea level rise document, you will find a menu to explain detail of this website, and where you can find the detailed information on how to pick those parameters. So it's pretty clear. If you can download it, read it, you will know better. Yeah. And after you pick the site, specify time period. So I specify 100 year here from 2000 to 2100. So 100 year sea level rise. So I pick USE projection from USE formula and the sea level change. And then I see the low rise, intermediate, and also high. So you see 3 curves here. And then also you can print a table. So if you give you a value for every year, and this is 101 value here, and then you can save this file, and then later on read to CMS, so as a sea level rise curve. And then when the model runs, it will read the boundary condition, read the sea level rise, and then merge these two, and then get your boundary forcing as shown by this equation. And so in the model, and mostly you need to do is update your boundary condition for this kind of scenario. And then you can go to map module. Here is the boundary condition, right? You right click the water surface elevation forcing, and then choose assign boundary condition. And then you come to this this window here. You see the example I show here, I use a tidal constitute, and I pick six tidal component, and from this link, it's a location in New Hampshire, because that location is close to the study location, Merrimack Inlet. That's the closest location. We pick tidal component from that location. So there's you see the amplitude and phase for M2, S2, N2, K1, O1, P1. So this is 6 component. And then after that, so we check water surface elevation offset or sea level rise, sea level change. And there's a constant or curve. And you click this one, you pick either one. So here we select a curve. We select curve, and then we click this figure here, this small figure here, and then we get open up this window. And then for this testing case, I really doing like a 2-day simulation at 2 meter sea level rise. It's not real. It's a 2 meters. That's impossible, right? But just show you how this work in CMS. So this is the column is a time and meter, and then hour 0 is 0, hour 24 is 0.5, hour 48 is 2 meter. So and then you click OK. So your sea level rise curve setup is ready to go. Yeah, that's how simple it is. And this is a NOAA website. I know it's a tide and current website. So if you go there, you can find many coastal gauge and a Great Lake as well. And then you can find a tidal component for this location. This is Fort Point, New Hampshire. And we pick a 6 component tidal component from here, amplitude and phase, all from here. And then remember to set up the time data unit is meter, and time zone is GMT or local. Here most of the time when we run CMS, we use GMT. Yeah. So after that, you save project, export the CMS-Flow, and then you are ready to run. Yeah. So export CMS-Flow. So this is a simulation result, and the 2-day simulation. So you remember we set up a 2 meter sea level rise. You see on top of a tidal signal, you see the mean water level goes up, right? This is from the model result. You see our output is every hour for 2 days. Some more detailed information you can find is in this technical note. It's published in June 2019, and the link is below the title here. And also in this technical note, we have a different example. It's a idealized inlet long-term simulation. Is a study SERP is conducting right now. It's a 100-year simulation. There's 2-meter sea level rise, and we run the model for. In fact, we use a morphologic acceleration factor here. We really run model for 10 years, and the acceleration factor is 10. So its morphology change is equivalent to 100-year change. And then on top of that, we put a sea level rise curve from 0 in, I don't remember which year we started. It's 100-year sea level rise from 0 meter to 2 meter. And then there's some model output and analysis in this technical note. So combine this, you can check the note for more detail. And yeah, that's about the presentation.